The large language models that we're looking at today are trained exclusively on language.
Not all of them. No. So things like Gemini are now trained with images too.
Images and also movies. Yeah. And what about, like you mentioned just briefly before, being able to interact with the real world, reaching out and touching things?
Right. That would make them even better at understanding space and things like weight and force. The problem with that is the real world has a natural timescale, and you can't give training data for doing this that goes thousands of times as fast if it's really doing it. You can play back training data, but if you have it interacting with the world, you get a natural timescale for the world, which means you can only get a certain amount of experience. So you only live for 2 million seconds. Sorry, 2 billion.
2 billion seconds.
2 billion seconds. Well, you're going to live for 2 billion and a little bit. I'm already in the little bit. That means you can't get more than 2 billion 1 second experiences, even if you didn't sleep, which is very little experience compared with a large chatbot.
And if the chatbot can get these real-world experiences, even time-limited, they'll still be able to share them with each other in the same way.
That's the point of the sharing.
Yeah.
You can now have 10,000 of them. Each of them is going slowly, but they can share what they learn, so they can get through a lot more data. And for AI agents, that's going to be very important, because an AI agent that's interacting with other AI agents on the web, there's a natural timescale to that. You can't just speed that up and run it through very fast, because you need it to be actually living in that world and interacting. But if you can have lots of them that learn from each other, that share what they learn, they're still going to be able to learn a huge amount. I believe in the future what's going to happen is, what we're seeing now is we're hitting kind of data problems. We've absorbed all the information on the web that you can just steal without paying anything. That's not what I was instructed to say when I was at Google. If you look around for what AI systems don't have any problems with data limits, one example is AlphaGo or AlphaZero, where they're playing games. And what they do is they play against themselves and see who wins to learn what a good move is. And that way they can generate infinite amounts of data. They don't need any external data put in. It's the same with mathematics. Mathematics is kind of a closed system. You can make conjectures, see if you can prove them, make another conjecture, see if you can prove that. And you can be doing that with no external input of data. So those kinds of systems can run all the time and get smarter and smarter. And I believe that's going to happen with large language models eventually. In fact, I think it may already be happening at Google, but I don't know anything about that inside. So at present, the large language models are trained to predict the next word. And that's very like the very early Go playing programs. They were trained to predict the moves that experts would make. So you give them a position, and you know what an expert did there, and your neural net has to predict what the expert would do. And there's a limited amount of data for that. And eventually you get to be as good as the experts, but not much better. And that's that. Then they realize they get them to play against themselves, and they generate infinite amounts of data. So no longer any data problem. So what's the equivalent for language models? Well, at present, you just try and predict the next word. But suppose you have a model, it has some beliefs, and it sort of thinks to itself, well, I believe this and I believe this, and it does some reasoning, more thinking to itself, and it says, so I should believe this. But I don't believe that. So there's something wrong somewhere. That provides a signal for doing some learning. And it could be offline, not talking to anybody, but just looking at internal consistency of its beliefs. You need to interact with the world a bit. It's not like mathematics, where it doesn't need to have anything to do with the world. You need to interact with the world a bit when you start off and learn from people. But then you can be checking for internal consistency and generate huge amounts of data that way. And those systems presumably will be working and thinking and getting better when they're not talking to anybody.